Good morning, good afternoon, or good evening, depending upon where you live around the world. Yep, I can't let it alone, can I? I was making comment once that played in the back of my mind, and it was regarding how this curved piece of the tube from the hub can be inserted on the inside as our interface plate because it's already sort of pre-curved to the inside shape of the hub itself. But, of course, it having a slightly different diameter or radius or curvature means that there is a little bit of interference on the edge points. I then said, but that's not necessarily a bad thing. And what I was meaning there was that as the strip here moves back ever so slightly, maybe 0.2 of a mil, I've just typed it in, it'll touch on those 2 points and sort of self-align. Yes, it would be better, be more elegant to have it touching completely along that inner surface, and to be fair, a little bit of a touch of the belt sander on the edges would pretty much make it flat and bed into that inner surface. But in the back of my mind was, it's not necessarily a bad thing having a plate touching on those 2 edges. Then I made the comment that this isn't a high demand area, and the load put upon it, or any part of it, probably is not going to be that great. What if I don't even make, and you can see it, I've given away the punchline already, as it were. What happened if I don't even go to the extent of cutting strips out of the tube, but just use a 25 or 30 millimeter wide flat bar of X millimeter thickness, in this case 5 millimeters. After all, isn't there a washer, or there's actually several washers, but isn't there a washer that will insert pressure or apply pressure with you can say a slightly dispersed manner, because it's not very thick, it's only 2 millimeter thick, but the pressure would be exerted largely against the very edges of the flat bar, and something would have to deform for it then have to deform before it becomes a problem, which it probably wouldn't be even if it did deform. Did you follow that logic? Well, good on you if you did, but it's unlikely that any demand put upon this to resist bending would ever occur. Now, again, engineers, I accept your slapping because it's assumption with no valid justification is just a guess. And yes, that's dead right. I'm guessing. But when we put down bottom plates, we generally use a 3 millimeter thick washer. It's a 50 by 50 millimeter 3 millimeter washer. And when we wind down the nut sometimes on it, a washer and nut, we see the damn thing bending. Now that's being supported by the wood, but bend it will, because the holding capacity of one of those 12 millimeter, they are a sleeved anchor and or a set in place bolt, can exert extreme pressure. Now, in some circumstances, they will require you to put a 5 millimeter washer in. I've never had to do it. There's none of the jobs I've had to follow the engineer's requirements requires you to put a 5mm, but nonetheless there are 5mm washers available for that same situation, 50mm square, etc. They don't bend. Well, they don't bend easily. That extra 2mm is quite significant. And I was thinking, well, hang on. This is not that situation. It is not being wound down. I doubt if we could get enough pressure on this screw into the end grain to deform this. And I'd be a bit worried if I could because of the stripping potential for the end grain and thread, etc. So, what would the downsides of this be compared to this? Or worded another way, what is the benefit of this compared to this? And yes, there is a benefit because of what I said. There is no, you eliminate any chance of deformation. Okay? And therefore, if there's no deformation capable to be had here, the washer can't bend either. The two being dependent, interdependent, or they interreact on each other, or possibly. For this to bend, there has to be a lot of pressure put on this area. Now, let's assume, as I said, that that's not going to be the case. Wouldn't this be easier to make? Well, yes. It gets rid of a whole process. You just go and buy the stock bar, you can get it. In fact, wait there, I'll bring up my chart and see what thickness we can get. Yep, and here we are, and we can have 25 by 3, 5, 6, 8, so we can beef up very easily the thickness of the flat bar. 6mm, 8mm. That is really heavy, and there's no chance of it bending. Not under these circumstances. We could go 30 by 5. Again, I'd rather go a little bit narrower and thicker, just to make things easier on me. So I'm going to have to give that some consideration. In fact, we know that the maximum thickness of this is 5mm, hence that's why I made this one 5, and we just flat off the edges, so that's 5mm, that's 5mm. Yeah, very simple. The other thing was, I was a little bit underwhelmed by the sloppy fit of the plastic tube on the assembly. It looks all nice and neat here, doesn't it? And that's the way I'd like to see it act in real life. But what tends to happen is, because this has got a larger diameter, it tends to drop down so that the inner surface rests on the shaft of the screw, and therefore it kind of is not a balanced assembly. So it would be better if the plastic were solid and a hole drilled in it. So now it requires me to go to a plastic supplier and see whether you can get this sort of plastic. It's a polyethylene in a solid rod. My initial investigation, and if I'm correct, this was a medium density polyethylene. You can't get in a rod. You can get the high density, but not the medium density. So it'll be a case of ask and find out. But still very happy with using that. It doesn't have to be that particular plastic. It's any plastic that can be obtained in a 25mm rod, thereabouts, and easily machined like this is. It planes well which I've done in the past, and it cuts well. So therefore, I would like to chase it down. Plastic suppliers could offer up an alternative, of course, and that's the beauty of asking people that know more than I in their respective fields. So, yes, interesting. I think I'd go down this route rather than this, simply because of its simplicity, and it may well be that no, I'll stop there. More simple, able to be, it's not going to cause any dramas, I don't believe. Okay, as I said, I'll stop there. The next stage is to figure out the demands of the lower leg and how to tie it to the ground, because this type of assembly, which is the very bottom hub assembly, has got no facility to hold down to the ground. Now, I had thought about, well, having a plate welded onto this, but again, that goes against the design philosophy of what can we do with our simple tools that won't bite us. Now, welding, and I've got a welder, I've got an arc welder and a MIG welder, but in our jurisdiction, if we were to use this, again, at home, just do it, but if we were to use this and required a permit, it would have to be welded by a certified welder, which would be wise when you consider the quality of my welds anyway. But if we can eliminate the demands in that area, probably not a bad idea. But if this were to be a permitted job, then I probably would have had to have engaged the services of an engineer to get their tick of approval or their suggestions. Okay, no, we'll leave it at that, and I will get back to you when I have anything that is worth a video. Okay, see you in the next one now. Bye.